Hi friends, welcome to Coordinate, and today we want to understand the first scheduling algorithm, which is called first come, first serve scheduling algorithm. Now, like you can tell from the words first come, first serve, we can define this algorithm as simply an algorithm that is used by the operating systems, even networks, to efficiently and automatically execute queued tasks. Now, the processes that are executed in the algorithm of first come, first serve, they are executed based on their order of arrival. The order of arrival is very important when it comes to first come, first serve as a scheduling algorithm. For example, we don't expect the process that arrived as the very last process to execute first, because it's not last come, first serve. No, this is first come, first serve. The order of arrival is very important. Hence, the process that arrives first will be executed first. The process that arrived second will be executed on the second position. The process that arrived last will also be executed at the far end as the very last process to be executed. So this is first come, first serve scheduling algorithm. Now let's look at this question and see how we can analyze and of course answer this question. So we have the processes, process 1 with 7 as the burst time, the total time that process 1 will take the CPU or will be worked on by the CPU. Then we have process 2 with 24 as the burst time. Then we have process 3 with 5 as the burst time. And then we also have process 4 as 13 as the burst time. So we won't of course execute or answer this question based on the way the processes are underlined or are presented here. No, because we don't know the order of their arrival. First come, first serve. We don't know if process 1 arrived first. We don't know if process 2 arrived second, process 3 third, process 4 fourth. No, we don't know. Else we need to base more attention on the question. So the question now reads, suppose the process arrived in the order of process 1, process 4, process 3 and process 2. That is the order of their arrival. First come, first serve. Hence, process 1 will be executed first, followed by process 4, followed by process 3, and lastly process 2 will be executed last, although it isn't presented on the far end as the last thing here. No, hence process 2 will be on the last because it is first come, first serve. And then the question continues. Okay, now calculate the waiting time for each of the process. And lastly, calculate the average waiting time for all the processes that we have in this question. So to do that and to answer this question, we'll first see and understand how we can translate the same question into a Gantt chart. So of course I've just copied here the processes and definitely also their respective burst time. Burst time, don't forget from our basics, the previous video we said it's simply the total time that the CPU will take to continue and to process obliquely the processes that are here. So suppose the arrival is process 1, process 4, process 3, process 2. So we need to present this information in a Gantt chart. A Gantt chart is simply a chart. Now, in a certain way, it is designed just like the way we have. Is it the pie chart? Is it all different types of charts? So, a Gantt chart, I view it as simply a technical way that we can use if we want to implement or to read or to represent this information that we've been given here, and of course also here if we want to translate them in a way that will be more vivid enough to understand and extract the waiting times for all the 4 processes that we've been given. So even in an examination, please don't forget, always start by plotting a Gantt chart. When you make a Gantt chart, then definitely it will be easy for you now to extract the waiting times for the first come, first serve scheduling algorithm, because data will be clear, everything will be clear. You will see and clearly understand what is definitely happening. So we have process 1, it arrived first and definitely it arrived at 0 as a millisecond. All the numbers that are here are representing ms, which is milliseconds, as that's of course the actual time that the CPU will take to process each and every process that we have in our question. So process 1 arrived in the CPU, of course, at 0 milliseconds, and by then the CPU was active for 7 milliseconds because that's the burst time for process 1. After the process 1 was done, the completion was done, don't forget the order says it is process 4 that came second. So process 4 again arrived in the CPU. The execution actually started from 7 milliseconds towards 20 milliseconds. Why are we going towards 20 milliseconds? Because the burst time for process 4 is 13 milliseconds. Hence 7 plus 13, definitely it's a 20. That is what we are doing right now, and this is a Gantt chart. And then after process 4 executed, after the entire execution of process 4, process 3 now came and to the CPU from the ready queue. I'm sure you understand the ready queue because that's where process 3 was whilst the CPU was executing process 1 and process 4. So it came from the ready queue because it was the third process to be executed, and then it executed starting from the 20 milliseconds where process 4 left off towards 25 milliseconds. Why are we going towards 25 milliseconds? Because the burst time for process 3 is 5. Hence 20 minus 25, definitely it's a 5. And lastly, we had process 2 as the very last process to be executed by the CPU, which started using the CPU from the 25th millisecond up to 49th as a millisecond. 25 minus 49, it's definitely a 24 as the total number of best time that the process needed to use the CPU for complete execution of this process. And if we were now to extract the waiting time, definitely we can tell, okay, process 1 waited for how many milliseconds? Definitely it's a 0 because it was the first process to arrive. And from there, process 2 waited for how many milliseconds? Process 2 had to wait for 25 milliseconds because it was the last process to be handled. First come, first serve. It's actually the same with last come, last serve, because if you come last, definitely you'll be served last. So it had to execute and wait for 25 milliseconds. You can tell where we are getting the waiting time. Definitely the number that precedes the box where process 2 is for 25 milliseconds, and this is what we are saying here. And from there, process 2 had to wait at least for 20 milliseconds because this is the total number of milliseconds that process 2 had to wait. Why was that process? Because this is the total number of milliseconds that process 3 had to wait. Why was process 3 waiting for all these milliseconds? Well, it's because there were two preceding processes that arrived first. First come, first serve, and the CPU was active for 20 milliseconds. Hence the waiting time for process 3 is 20 milliseconds. And from there we can tell also the waiting time for process 4 is simply 7 milliseconds because by then the CPU was working on process 1. So these are the waiting times for the respective processes. So what is now the average waiting time for the entire processes? Well, to calculate the average waiting time, we need to add all the waiting times for each and every process in our respective question and then divide by the total number of processes. I mean, this is the actual formula we use even when calculating the average. Average marks in class, you add all the marks divided by the total number of students in class. Hence, this is what we are also doing here. So when you add the waiting time for process 1, waiting time for process 2, plus waiting time for process 3, plus waiting time for process 4, divide by the total number of processes, which is 4, we are getting 7.428 as actually the milliseconds that are being denoted as the average waiting time for each and every process. Please, if you don't understand, you can rewatch the video, and from there please subscribe and comment for we to know what we should handle and what we should actually implement in our next session, as we will now understand another scheduling algorithm which is called shortest job first scheduling algorithm based on the preemptive scheduling. Of course, we've understood what is preemptive and non-preemptive, so definitely we'll also come and see on the other session on how we can implement a non-preemptive shortest job first scheduling algorithm. For now, please don't forget to subscribe, and you are on CodeNet.